In this video, I'll show you how to use the normal distribution to do probability calculations in Excel. So I'm going to use an example of a tire company that has done a bunch of road testing on its tires and discovered that the mean number of miles out of this particular type of tire is 36,500 miles, and the standard deviation is 5,000. What we want to calculate is the probability of a tire exceeding 40,000 miles based on the data. Okay, so one way to tackle this is to calculate the standardized value, which we'll call Z, and Z is equal to the X value, which is 40,000, minus the mean, 36,500, all divided by 5,000. So the standardized value is Z equals 0.7 in this case. And then the probability that a standard normal random variable will exceed 0.7, that will tell us the probability that a tire will exceed 40,000 miles. And underlying all this is the assumption that the data follows a normal distribution. Okay, so one step towards finding that probability is to find the probability that a standard normal random variable will be less than 0.7. And then we can subtract that value from 1 to get the probability that we want. So to find this probability that the standard normal random variable is less than 0.7, we use this function here, norm.dist. To find the arguments, we'll click fx, and it tells us that the first argument is the value for which we want the distribution. So that's the 0.7, d2. The next number is the mean, which for a standard normal random variable is 0. Next number is the standard deviation, which is 1 for a standard normal random variable. And then the last argument is a logical value, which for the cumulative distribution function is set for true. And that's what we want in this case. So the result there tells us that the probability that a standard normal random variable is less than 0.7 is 0.7580. And as I mentioned before, subtract that from 1 to find the probability that a standard normal random variable exceeds 0.7. And so that's the answer to the question. Just a quick note here, we could actually use this norm.dist function to get the answer without going through calculating Z first. And the way that you do that is for the first argument, put the cell that contains the actual data value, 40,000. So C2, and then for the second argument, instead of 0 for the mean, we'll use the actual mean of the population distribution that we're assuming, which is 36,500. And then instead of using the value 1 for the standard deviation, use the actual standard deviation for the population that we're assuming, which is 5,000. And then the last argument's the same. And you can see that the calculation result is exactly the same. Okay, what if we wanted to work the other way? Okay, find the mileage that corresponds to a probability in to the left of 0.1. Okay, so if I have 0.1 for that probability, then how can I calculate what Z would be to give me a probability of 0.1? Well, here we use this function here, norm.inv, and this has 3 arguments. First one is the probability. Okay, so that's the 0.1. So that's in cell E5. And then again, the mean and the standard deviation, if we're working with a standard normal distribution, that's just going to be 0 and 1. So this is telling me that when z is equal to minus 1.28, there's a probability of 0.1 to the left of that z number. And then I can work backwards from my formula for finding standardized values to figure out what x that corresponds to. So remember, when we calculated z from x, we subtracted the mean and divided by the standard deviation. To go backwards, we multiply by the standard deviation, which is 5,000, and then add the mean, which is 36,500. And that tells us that the x value, 30,092, is the value that will have a probability of 0.1 to the left of it. And then finally, just to wrap up, we can go directly to this result without having to go through calculating z first if we just, instead of putting 0 and 1 in for the mean and the standard deviation, put in the actual population, assumed population mean and standard deviation. And again, we'll get exactly the same result.